My name is Emre. I'm a fourth year electrics and electronical engineering student in Bilkent University. I designed a low noise amplifier for my microwave engineering lesson. This is my PCB. It operates on a 13 volt DC input and my center frequency is 330 MHz. My bandwidth is 10% of the center frequency. At my center frequency, the noise figure is 1.1, but it changes between 1.1 and 1.2. In the low cutoff region, it is still 1.1, and at the higher cutoff region, it is 1.05. These are the noise figure measurements of my circuit. Okay, these are the S parameter measurements of my circuit. I connected my circuit to a network analyzer. The ST1 parameters are shown here. The marker 1 is on the low cutoff frequency, the marker 3 is on the high cutoff frequency, and marker 2 is on the center frequency. These are the gains. The input reflection coefficients are these ones, and the output reflection coefficients are these ones. So this is the schematic design of my circuit. I use ADS for my simulations and also for the layout design. The schematic consists of input and output matching network, biasing and a stability network, and also there is a small degeneration inductance in the emitter for better input reflection coefficients. By analyzing the datasheet of the BGT, the best biasing points are chosen as these, and the biasing network is designed to get these values. This is the final layout design of my PCB. The dimensions are approximately 2.5 cm to 5.8 cm. And these are the S parameter simulation results of my layout. The gain in the center frequency is approximately 17 dB, and the worst input reflection coefficient in the band is minus 8.7 dB approximately, and the maximum output reflection coefficient in the band is approximately minus 19.3 dB. Finally, these show the noise performance of my circuit. The simulations give less than 0.7 dB. However, my real life PCB gave approximately 1.1 dB noise in the band.